Okay, so let's start with this performance task called saving money. Um, let's read what it says at the beginning. Every day on her, okay, guys, I can't have talking while I'm reading. Every day on her way home from school, Jen uses $1 to buy a bag of chips. The chips cost 75 cents, and she saves the remaining quarter on her in her change jar. Jen buys 5 bags of chips per week. At this rate, how long will it take her to save $10? Okay, let's see here. Let's figure out how much money is she saving in 1 week? Well, every day she saves a quarter. $1.25 because it's 5 bags of chips, right? And each day she saves a quarter. So let's say Jen saves $1.25 every week. Okay. How many how many weeks will it take her to save $10? So remember, every week it's $1.25. So in 2 weeks, it would be $2.50, right? 125 plus 125. Another week would be another $1.25. So that would be 375. Think about it that way. How many weeks will it take her to save $10? $1.20. Well, it would be $1.25 because we want to know how many weeks, not how many days. There's a couple of ways you could do it. You could add 125s, right, until you reach a month. So a month would be 4 weeks. What's 4 times 125? Oh, 8 weeks? How do you get 8 weeks? In 4 weeks, you get $5. Another 4 weeks would make it 10. So it would be 8 weeks. We can always check it, right? So we're saying 8 weeks. If you take $1.25, multiply it by 8 weeks, do you get 10? Do you get 10? This is 40. 16, 4 is 20. Right? 8 times 1 is 8 times. Yep. So it's going to take her 8 weeks to save $10. All right. So let's write an equation. So for part B, it says write an equation. So now we're getting a little more algebra to show how much money Y. So money is going to be represented by Y. Jen will save after any number of weeks X. So X is going to represent the weeks. So we want Y, the amount of money, equals something times X, the number of weeks. It's that something we have to figure out. And basically, that's her rate, how much she's making every week. How much money is she saving per week? 125. So, in other words, you tell me how many weeks have gone by, and I can tell you how much money Jen has saved. Because this is the number of weeks. and this is the number, the amount of money. So it's y equals $1.25 per week times the number of weeks. Okay? All right. So now we're going to create a graph to represent the situation. So what are we measuring on the x-axis? What does it say we're measuring with x? Weeks. So we got 0 weeks, 1 week, 2 weeks, all the way to, I think, 10. Sorry. 4, 5, 6, 7, 8, 9, 10. Okay. And on y, we're measuring money in dollars. So I'm going to write sideways. Dollars. And that's how much she's saving. So $1 all the way to $10. There we go. So there we set up our graph. Let's go ahead and use this equation to help us figure out the graph. So at the very beginning, how much money has she saved? The very beginning. Before she bought any bags of chips. She has $5 at the beginning? How can we tell? Well, $1 wouldn't happen after 1 week, right? After 1 week she'd have $1.25, so maybe this much. But at the very beginning, before she bought any chips, has she saved any money? No. She starts off with 0, nothing saved yet. After 1 week, it's $1.25. After 2 weeks, it's $2.50. After 3 weeks, it's how much? $3.75. After 4 weeks, she's saved $5. How much has she saved after 8 weeks? $10. Okay, we got enough points to make a line. Everyone has a ruler, right? Let's connect those points and make a straight line. Hmm. Hmm. Okay. And underneath, write Jen, because we're going to make another line for Mark in a little bit. Okay. So this line represents how much money Jen is earning. Okay. Now, let's move on to Mark. Okay, so let's read the next part that talks about Mark and how much he's saving. Mark is also trying to save money. He already has $3 saved and puts $1 per week away in his piggy bank. Instead of a jar, he has a piggy bank. This can be represented by the equation y, the amount of money again, equals x, the number of weeks, plus $3. Okay, let's do this. Let's go ahead and graph a line for Mark. How much money is he starting with? 3. So at 0 weeks, he has $3 already. Right? And then he adds $1 every week after that. So after 1 week, you add $1 to $3, how much do we have? We have 4. So after another week, you add $1 to $4, you have $5. And then you add another dollar every week. So you move up $1. Do you think these lines are ever going to meet? Yeah, it certainly looks that way. They're going to cross. So let's make this line now. This is the line for Mark. Okay. So does it look like Jen's going to cross Mark and go beyond Mark, or is it Mark going to be crossing and going? Yeah, it looks like Jen's going to cross over. All right. So let's figure out, will Jen or Mark save $20 first? Who's going to hit $20 first? Jen. Does everyone agree it's Jen? Okay. Let's figure out, let's do the justify part. How do we know that Jen's going to save $20 before Mark? Let's figure out how long it would take them. How long would it take Jen to save $20? Use the fact 16. Would you agree it's 16, guys? Look, how long did it take her to save $10? 8 weeks. $20 is twice 10. So you double that 8 weeks. It's 16 weeks. Let's look at Mark. How long would it take Mark to save $20? Well, he started off with $3, right? And then you're adding $1 every week after that. So count up from 3 till you get to 20. 3, 4, 5, 6, 7, 8, 9, 10, 17. So it would take him 17 weeks. This next part, if you look at the graph carefully, you can answer it. Imagine you have made a graph to represent the money Mark has saved. Explain why Mark's line does not start at the origin and Jen's line does start at the origin. So they're asking us, why is Jen's line starting here and Mark's line starting at 3? Answer that. Go ahead, and I'll give you some time. Answer that. And then we're going to go on to the backside. Everyone should be able to check in with your partner, make sure you agree. But why does Jen's line start at 0 and Mark's line start at 3 on the y-axis?
Where did you go back over?
Okay. All right, we're going to go on to the other side now. Similar triangles. Okay. So they're going to walk us through using rise over run to find the slope for this line. So we're going to start with Brandon. Brandon started at 0, -1 and drew a right triangle going up 2 units and right 3 units. Okay. Madison started at -3, -3 and drew a right triangle going 6 units, going up 6 units and right 9 units. We're going to draw and label on the graph. Okay, so let's start with Brandon. Brandon's going to start at 0, -1. Right there. So everyone put a point at 0, -1. Okay. Then it's telling us to go up 2 units and right 3 units. So let's do that. Up 2 units and then right 3 units. So we just did rise over run. Let's try the same thing with Madison. For Madison, they're telling us to start at -3, -3. And we're going to go up 6 units. And then to the right, 9 units. All right. So go ahead and label those 2 triangles. We have a rise of 2 and a run of 3, a rise of 6 and a run of 9. How are the triangles related? What's the connection between the 2 triangles, this one and that one? What do they have in common? What type of triangles are they, maybe? You remember when you describe triangles? If it has a squared off corner, it's a right angle, so it's a right triangle. So there's something they have related. Both are right triangles. Last year, and because they're right triangles, last year, do you remember learning about similar triangles? Similar triangles are proportion. So let's bring that from last year. Both triangles are similar. So that means they're in proportion. Find the slope of the line using Brandon's triangle and Madison's triangle. Okay, let's start with Brandon. So we want rise over run. So what's the rise and what's the run for Brandon? Here's the rise, here's the run. Give me the ratio. What over what? The rise is, and the run is 3. 2 over 3. Can I reduce that? Nope. So it's 2/3. Let's go on to Madison. That's going to be 6 over 9. And divide by 2, by 3 rather. And you also get 2/3. So that also happens because they're both right triangles that are in proportion. Okay? So the last part you're going to do is justify how the triangles relate to the slope of the line. Why can you find the slope using any 2 points on the line? So how was it that we were able to make this right triangle and that right triangle, and they both ended up being the same slope? I'll give you a hint here. Both triangles are similar, so the sides are proportional. So go ahead and write that down. So the sides are proportional. That's why 6/9 reduces to 2/3, or you can go 2/3 multiply by 3 and you get 6/9. Okay, so I'm going to leave that last question for you to answer and then turn it in. Okay.